Okay, so for this lecture now we're going to look at exercise and how does exercise affect acid-base balance and what does that look like? So those are a lot of acids that we produce during exercise, a lot of hydrogen ions. As we can see, whether it's carbohydrate, where we, through aerobic or anaerobic means, we can produce carbonic acid, lactic acid, all of those increase hydrogen ion concentration. If we're breaking down fatty acids through beta oxidation, we can produce ketone bodies, which causes increases in hydrogen ion concentration. If we're utilizing proteins, which we do occasionally, we haven't gotten huge into that, but we do. If it's sulfur-containing amino acids, it's sulfuric acid. If it's other nucleic acids, other amino acids, it's phosphoric acid. We are producing acids there, and they, everybody, increase hydrogen ion concentration. And so this needs to be buffered. And so all of these during activity or issues, and whether it's carbohydrates, fats, or protein metabolism, we need to break these down to buffer these to keep pH normal. So how do our cells do this? How do we pull this off? There are a lot of buffers in the body. There are ones inside of cells. Proteins are a big one, as we'll see. Actually, they are the biggest one. Bicarbonate, probably the most important one. We'll see, especially in the blood. There's phosphate groups which combine some of these outside the blood. Hemoglobin also plays a minor role. And so there are some buffers that we have built in to deal with these acids during activity. And as we'll see, bicarbonate is the one we're going to talk about most. Not because it's in highest concentration, but it's the one that we probably have the most control over and its role in acid-base balance. All right, so let's come up with the shocking news of the day. Here we go. When you exercise, you produce lactic acid. I know, you had no idea. When we engage in an activity, we produce lactic acid. And not a shock. Hydrogen ions can impair performance. And we can go through all the reasons why. When we talk about how muscle cell contracts, we'll see that hydrogen ions could potentially play a role in affecting that. It can play a role in the endocrine system. We've already talked about bioenergetics, where enzymes, PFK, other ones hate changes in pH. And so there's a lot of things here where if we have an acidic environment where pH is dropping, which happens during exercise, that's going to impair performance. It's going to be something that limits you from doing what you want to do. And so we want to deal with this. And so as you can see, intensity has a role, the amount of muscle mass, not surprisingly, activities that use more muscle mass will see greater drops in pH. If exercise duration is long, we may see some changes, different changes in pH. Another thing to grasp is that generally changes in pH are local. In other words, if I'm engaging in an activity, if I'm doing bicep curls, right, I'm going to see a pH drop locally in the muscle much more dramatically than I will in the blood in my entire body. Now, I'll still see the blood pH drop, but not the same as locally inside the bicep muscle. And that's key to understand. That's the reason why you can max out doing bicep curls till your biceps drop, but then still walk and still leave the gym and do stuff, even go for a run, because these changes in pH are local. Okay, so how then do we buffer this? Well, we've already talked about this actually. We've talked about respiratory and metabolic means to buffer and deal with pH. We talked about respiratory alkalosis and acidosis, metabolic alkalosis and acidosis. So we already know that if we're going to buffer, if we're going to alter pH, if we're going to deal with hydrogen ions, there is a respiratory means, and then there's what we call renal or metabolic means. Now, you can guess which one of those during exercise, when you're running hard, acutely, which one of these is going to have a greater benefit? Well, not surprisingly, respiratory, right? The kidneys can't respond quick enough to get rid of these hydrogen ions. And so we have to increase breathing rate. And so during activity, we generally say the respiratory response is a bigger deal at least in getting rid of CO2. Now, that doesn't mean the metabolic part's not important. We're going to talk about bicarbonate. Bicarbonate plays a huge role, but we blow off CO2 immediately. As soon as we start to engage in activity, we increase minute ventilation, VE, we get rid of CO2, and we hopefully deal with these changes in pH. So we see this during exercise. Well, how well does our body do this? Well, truth be told, one of the biggest roles when it comes to buffering lactic acid in muscle is through intracellular proteins. You have proteins in your muscle. We'll talk about that soon. Actin and myosin, there's other proteins there as well. Truth is, in muscle, those proteins are the best buffers. Now, you do see bicarbonate. Bicarbonate has a role, other phosphate groups. But in muscle, proteins have a role. But when we get to blood, that's a different story. When we get to blood, bicarbonate has a large role. And this is where we open the door to saying, okay, well, when it comes to exercise, it's hard to get more proteins in your muscle. It would be nice and easy to say, well, eat more protein. Well, your body can only take in so much of that protein. Anything it doesn't use, it's going to store as glycogen. It'll store as something else, or honestly, you'll excrete it. And so simply increasing intercellular protein is not an easy answer. But bicarbonate's a different story. I mean, maybe if we could increase bicarbonate somehow, that potentially we could alter pH. We could, in some activity, maybe delay these changes in pH. And so research has been done on this. And this is where a lot of classes, I always tell the story. When I was in grad school, I actually tried this. My roommate and I were running and took some baking soda, which is bicarbonate, sodium bicarbonate, put it on a pizza, ate some of the pizza. We kind of looked like we were dogs foaming at the mouth with all the white stuff everywhere. But the idea being, hey, if we can take this in, then maybe we'll run faster. I have no scientific evidence it worked. But there is research that shows, yeah, actually, potentially, this may work. Now, there's not a lot of research that shows a huge improvement. But at least the theory is there. The theory is there is, okay, well, sure, if we can ingest bicarbonates, if we can alter pH before exercise, then yeah, we can maybe delay that drop in pH during exercise. Now, you can probably guess there's issues with this. You can probably guess that there's a reason why runners and athletes aren't downing baking soda like it's Gatorade. For a lot of reasons, it's not enjoyable. It causes you want to vomit. It can cause alkalosis. There can be issues with that. And so this isn't an easy answer. And dealing with buffers and taking bicarbonate isn't an easy way to improve performance. But it has been something that's thrown out there. One way we can utilize acid-base balance and manipulate it to intentionally improve aerobic, although some kinds of anaerobic performance as well. So we'll get more to that ergogenic age way later in the semester. We'll talk about this and a lot of other ergogenic age means to improve performance. This is just one of the thousands of ways we could try to do that. So our next chapter, we're going to look at the nervous system. We're going to intro the nervous system. And so we will see you in that chapter.